All right, well, thank you, Mike, for giving me kind of an introduction here. One of the challenges that you always have when you're looking at economics is cost structures are very different for each individual operation. A lot of it's based on the amount of acreage that you're farming, the type of equipment you are running, so there's a tremendous amount of variability in some of these estimates. So what we're looking at here is kind of how field capacity and field efficiency will affect different cost categories. So when we're looking at costs, we typically break them down into fixed and variable costs, so I'll talk about that a little bit. Machinery costs, given where some of these technologies are substantial. It is incredibly expensive to operate equipment, particularly if you're looking at buying new equipment. There's always that trade-off. There's a trade-off between capital recovery, so your depreciation and your interest expense, versus repair and maintenance. You run older equipment, typically your R&M or your repair and maintenance is typically higher. If you're running newer equipment, typically you've either got a loan payment or you're getting higher depreciation expense. So what I'm going to do is I'm going to walk through a couple scenarios. You can kind of look at how you can evaluate maybe a purchasing or upgrading decision and look at how that is affected. The other one that I do want to talk a little bit about is the risk of getting that crop planted. Again, we have an undefined planting window each year where we have to be able to get that crop in. There's a value for surplus or deficient machinery capacity that we need to be able to attach to the planting process. Mike mentioned machinery capacity. That is what we look at on the economic side. That is driven by field efficiency. So I'll touch a little bit on that. But essentially what we want to look at is the trade-offs between different capacities, whether it's through upgrades in speed or upgrades in width. So if we look at the data, we use the data that Mike was talking about, the time data that they collected to end up determining the field efficiency, which is a function of planter speed, planter width, and perimeter to area ratio. We also looked at days suitable for field work in Tennessee, and this is averages from 1995 to 2017 to kind of determine what that planting window is. And then we looked at some standardized calculations for machinery costs. And the reason why we looked at standardized ASAB calculations is so that we can end up comparing side by side. We're using a consistent method so that we can look at the changes as we change certain variables. So again, Mike mentioned we came up with this equation. So again, we came up with an efficiency equation as a function of width, speed, and perimeter to area ratio, and then there's a couple of interaction terms in there. As you increase speed, width, and perimeter to area ratio, you're decreasing efficiency. But again, what we're looking at is we're more concerned with capacity on the economic side. So we have that theoretical capacity, which is speed times width divided by the constant. Then we have to multiply it by that efficiency number. So once we get that efficiency number, we can determine true or estimated field capacity. You look at capacity risk, again, sufficient machinery capacity is required to plant crops in an undefined window. If you have too much, it's an added cost. If you have too little, then you run the risk of missing that optimum window. If you look at Tennessee, this is for May, looking at some cotton data. We typically have about 18.9 days. That's what average we have in May out of 31 where we can end up having days suitable for field work. There's a standard deviation of 4.1 days. That means at 95% of the time, or 95%, you're going to have a more than 10.1. The easier way to look at this rather than looking at a probability is to kind of look at a cumulative distribution. So if you look at that again, what this shows is if you have 50% of the time, this line right here, you're going to have 18.9 days or more. We're not concerned with the or more from a planting standpoint. The more time that you have, the better. So we're concerned with what happens if you have fewer. So if you look at, if you have 10% of the time, you're going to have less than 13.5 days to plant that crop in the optimum window. Now, if this window is changing, it adds a completely different set of economic variables, right? So if all of a sudden, over the past few years, we've seen some very wet conditions, if this window changes, it changes how much capacity you would need in order to get that crop planted within that defined window. So again, when we're looking at costs, we break them down into two general cost categories. Variable costs, which include repair, maintenance, fuel and labor, and then fixed costs, which include depreciation, capital recovery, and taxes and insurance and housing. So again, we're kind of putting everything in there to end up getting an estimate of what those costs are. Capital recovery, a lot of people confuse capital recovery with an interest or a loan payment. That's not necessarily the true definition of it. What we're looking at doing is if you have money, whether it's borrowed or whether it's your own personal, you should be expecting some type of return on that money. If it's borrowed, it's very easy to calculate. You end up picking your loan rate. If it's not borrowed, if it's money that you have on hand, then what you need to end up looking at is what's your next best alternative and what's the alternative rate of return that you would end up getting if you invested it. So again, you look at standard equipment cost calculations. We have depreciation. Depreciation is one that's a little bit tricky because by definition, if you're looking at fixed costs, you are not changing those costs as you're changing acreage, right? But is that really 100% accurate? And the answer is probably not. It is dependent on how often you were using that piece of equipment as to how that value has ended up changing over time. Interest, again, what you're looking at is an interest rate and some type of compounding period to end up determining what your costs are. So we take these costs as fixed. So they are incurred regardless of the amount of acreage that you are planting. Where you get the influence of field capacity and field efficiency is on the variable cost side. And essentially we break it down into three different categories. Repair and maintenance, fuel and labor, and these are a function of field capacity, which is CA. So again, each one of these are going to change as you change the amount of acreage and field capacity that you're looking at. So if you quickly take a look, these are those same capacities from the blocks that Mike ended up showing. We all know that when you're looking at purchasing a planter, you don't purchase based on your best field, you don't purchase based on your worst field. It is some aggregate. And where that aggregate is really tricky to determine, but what we're looking at, and the reason why we're looking at this type of data is looking at those field efficiency numbers. If you have lower field efficiency numbers, that's going to drop down your capacity. So again, when we get these capacities, we take a look at those 8 different blocks that Mike ended up having, have a max and a min for those capacities, and these are the numbers that we are looking to end up generating some of our cost estimates that we can compare across scenarios. So the first scenario that we look at, this is a 40-foot planter. We're looking at speeds of 4.57 and 10. This one is more of what we would call maybe a high-speed planter due to the purchase price of this piece of equipment, but we want to be consistent because Mike did a very good job of saying even though some of these planters are capable of going that fast, we're maybe not driving them that fast for a bunch of other different reasons. So again, what we want to look at is we want to look at what is those range of speeds and how does that impact what our capacity is. And then again, looking at what those field efficiencies are, because those are going to be different for every operation. And then again, we have some assumptions that we need in order to end up doing our economic calculations. These are going to be very different depending on individual sets of circumstances, but we try to be consistent across scenarios. And what the ultimate goal of this project is to do is to take option 1 compared to option 2 and make a decision aid where producers can end up taking a look, well, does it make sense for me to end up buying that faster planter, that wider planter, and what's that price point where you can end up making that decision? So it's a method to end up doing comparison across scenarios. So we try to keep as much of these variables as consistent as possible, but you do have to remember these interest rates, the price of labor, diesel price are going to end up dramatically influencing the cost one way or the other. So what we end up looking at here is this is the estimated total planter costs for that scenario that I just described, this one right here. If you're farming 1,000 acres versus farming 2,500 acres. So we took 2 acreage blocks and we ended up saying, okay, what is the total cost based on these different field capacities? Now these speeds, again, since you have a range of efficiencies, those range of efficiencies and those different speeds are going to influence capacity. So it's kind of a continuous function. The lower capacity has higher variable costs due to the number of hours that you're running that machine, right? Because when you look at those variable cost calculations, a lot of them are based on per hour estimates. As you end up getting into greater field capacities, you're spreading out some of those fixed costs, and so you end up seeing this downward slope in the cost function. Now again, this makes up both fixed and variable costs, and you can see as you end up increasing acreage, you're bringing down particularly those fixed costs, and I'll show how those costs kind of interact here. So again, this is that same scenario, but what we're looking at is the fixed cost to total cost ratio. And so again, when you end up having 1,000 acres, your capital recovery and your depreciation costs on a new piece of machinery are substantially higher. If you're spreading those fixed costs over additional acreage, you end up dropping it down. It becomes more of a variable cost question. So if you look at planter scenario number 2, this is a lower cost planter. We kept everything else the same so that we can make a valid comparison. We're still at a 40-foot planter, but you can see those costs come down dramatically. You end up going from, if you're going 4.5, you're somewhere in that 25 to 15, where you can get all the way down to 10. Now, the thing that I want everybody's to keep in the back of everybody's mind is, again, yes, everybody wants to have lower costs than higher costs. That's pretty obvious. But what's the risk, right? When you're talking capacity, you're running the risk of getting that crop planted because it's taking you longer, and I'll talk about that at the end of the presentation. Again, as you moved from higher capacities, you end up getting a greater proportion of costs associated with variable or fixed, to fixed to variable cost ratio, and the more acreage you end up having. This one is the 60-foot planter, same assumptions, higher price point again that we're looking at. Similar graphs where you end up getting more acres. I added a 5,000 acre option in here so you can end up seeing those cost curves getting down to that $20 or $30 per acre based on some of these higher speeds. But if you're in that 7 or lower, you're probably looking at substantially higher costs. A lot of that is the capital recovery of that initial purchase price. Again, you look at the percent of fixed costs as a percentage of total, and we see that upward sloping, but again, the shape of these functions end up changing dramatically. Now this is kind of the DAW moment, I guess, if you will, right? If you look at these costs, this is the low cost planter option, this is the high 40, and this is the 60. Well, it's economically beneficial to buy equipment at a lower price than a higher price. Well, that's pretty obvious. That's like when Mike said, you burn more fuel going uphill than you do going downhill. It's very obvious. But there is a component of this that is very important. So when you look at these ratios of fixed versus variable costs, it's really important to look at how these cost structures are for each individual farm. So again, what this bottom line here is, it represents the percentage of total costs that are coming from different categories. So when you look at fixed costs, you're looking at 85% of your costs on some of these high-priced planters that is going to end up being responsible for that capital recovery or depreciation, interest, and taxes, insurance, and housing, where you're only getting about 15% on variable costs. Now that changes as you end up reducing that initial capital investment over time. If you look at this one, this last one was for 75% efficiency. This is again for 65%. So again, you can see the difference in that field capacity based on efficiency. As you decrease your efficiency, you decrease your capacity. It's important to understand the percent of cost of fixed versus variable. Again, what you end up seeing is that there's not a huge difference in the change in cost in efficiency when you end up looking at total costs. So again, if you look at kind of that basic capital recovery decision, there's a simple test that you can end up using. You're looking at depreciation and interest costs. So you take what your purchase price is, less your salvage value, divided by the total anticipated useful life and your total acres planted. So in this case, if you have $200,000 purchase price, $50,000 salvage value, divided by 8 years and 1,000 acres, you're $1,875 into that on a fixed cost, just on average. Just a very simple, no dirty calculations on this, just a very simple estimate. You have interest at 3.5%. On 200,000, you're going to get 1,000 acres. That's another $7. So your total capital recovery estimate is $25.75. Now, if you look at prevailing custom rates for planting, one of the estimates that we had in our machinery custom rate survey was around $30 per acre. We had a wide range. It was anywhere between a low of 10 all the way up to $45 per acre. That leaves you $4.25 to cover your variable costs. So does it make sense to end up getting somebody to custom plant this? Maybe, maybe not. There's a bunch of other questions like me and Tyson were talking before, where can you get consistent access to that planter, right? If you're relying on custom labor, whether it's planting or harvesting, there's always that question of when you have an abbreviated window, who's the one that's at the very end of that window? Because if you're the person that's on the end of that window, you're running some risks. So, what is surplus machinery capacity worth? And again, it always depends. In economics, it depends on some of the assumptions, but there's an easy way to end up kind of getting a ballpark estimate of what that capacity is worth. So again, when we look at hours, these are the hours required to plant based on these different field capacities for the corresponding 40-foot planter scenarios. So you can see this 13.5, you remember from that distribution of days suitable to plant, this is kind of that threshold. So if you're above this line, you're running the risk of not being able to plant during that window. If you're below, the question is how far below are you in order to end up having a potential surplus machinery capacity. Again, you look at the 61, same story. Once you get into those higher acreages, again, if you're looking at only 13.5 days, you're running a tremendous risk of potentially not maybe being able to get that acreage planted. So this is the kind of the analysis that kind of brings it all kind of back together. So I went through the three scenarios again. I kind of rearranged them. So I have the low cost scenario first, number 2. You can see the speed, and again, this is from a perimeter to area ratio directly from the data set. It's one of the better fields. It's one of the lower perimeter to area ratios. You can see the field efficiencies that coincide with that. We have a 40 foot, and 60, but we're varying speeds as well. You look at the field capacity of 17.89 acres per hour, 2545, and 2651. The time to plant 2,500 acres is 140 hours, 98 hours, and 94 hours. Your total cost all in is $19.29, $33.25, and $36.48 per hour. When you multiply that planting time by that per hour, or you multiply the per acre cost by the total number of acres, you get a total cost of $48,213 to plant 2,500 acres, $83,113 for the higher planter cost, and then for the 60 foot you get a $91,192. What you do is you end up looking at, well, what's the difference in planting time between your different scenarios? So your base scenario of 140 and 98, well, there's 42 hours difference, and there's 45 hours between the base and the first, or the base and the second option as well. So if you look at what the cost difference is between these two numbers, the time premium that's being associated with going from this low cost option to this high cost option is $841 an hour. And that's what the value of that, or the perceived value of that surplus machinery capacity is. Now, one of the things, and again I want to highlight, these are cost estimates. The end goal of this is to end up looking at having something where you can plug your own information in. It'll give you a realistic estimate of what your true costs are, and where your capacities are, and how your risk is for your different planting windows. So again, evaluating those fixed and variable costs are very important when you're looking at a new purchase decision. Capital recovery, depreciation and interest is a substantial component of every new equipment purchase. It's one that is often overlooked. It can get incredibly complicated when you're looking at a capital purchase because there's also tax implications. So when you're looking at these different capital purchases, these are very simple cost estimates, but you do have to look at other factors that are going to influence your cost. This is another one that we used to dwell a lot on in economics, was the price of fuel. It really doesn't matter that much anymore. It's really not that big of a deal. Obviously, again, if you're looking at, you always want to end up getting, prices down as low as possible, but as a percentage of your operating costs, fuel and labor aren't that much. Now, me and Tyson have talked substantially about labor, which again, you can link those two categories, because if you have high capital equipment, so very expensive equipment, you probably don't want to just pull somebody off the street and say, hey, you go drive that $900,000 piece of equipment. So your labor costs are going to end up probably being reflected into the quality of equipment that you're running. Fixed costs must be distributed over sufficient acreage. So again, if you're talking small acreage producers, given the price of some of these new planters and other pieces of equipment, it's very difficult to spread out those capital costs over a small amount of acreage. So then you look at potentially going to lower cost or used equipment. Additional data on the true operating costs of some of these new planter technologies is something I think we would really benefit from. When you have a high-speed planter, are your repair and maintenance costs the same as a conventional planter? And I would wager no, they're probably not. But we do not have data on that. Now, there are a couple of assumptions that people need to be aware of when we're looking at this analysis. The first one is we're assuming that yield is the same between the two different scenarios. So when we're looking at this right now, if you are going from one planter to another, are you getting that same yield? Are you getting that same consistent seed placement? So if you have additional technology on this high cost planter, is that giving you a positive yield relative to the existing alternative or the other scenario? And that's a very important question. Again, we don't have enough data on that. The other one, and this is not as maybe a big a deal in Tennessee, but if you go up into the Midwest, does this new planter accomplish additional tasks? Are you putting down fertilizer with it? Then you're changing your entire equipment complement, right? You're no longer just planting, you're potentially minimizing the number of passes over your field. So again, if you can end up having multiple functions, that changes. This is another big one. I don't have a good answer for this, but if you're changing horsepower requirements, if you're going to a faster planter or a bigger planter, do you have to upgrade a tractor? Because there's a really big difference from a capital cost if you have to upgrade a tractor and a planter. And again, that tractor is likely not only used for planting, so then you're spreading out those costs over other functions, and you're looking at it from more of a total equipment complement standpoint. And again, that's something where it's real tricky to end up deciding, how much of that upgraded horsepower goes into the planter costs. Repair and maintenance, again, I mentioned that one earlier, where you have a faster planter. Is it fair to end up having the same repair and maintenance on that? And then this is the other one that's big about moving that window, is if you are shifting the days suitable for field work, how does that affect your crop mix? So if you start planting corn and then you end up looking at cotton and soybeans, if that window changes and you maybe can't get that corn or that cotton in, then you're looking at a different crop mix, right? And so that changes your cost structure, particularly if you're looking at cotton to an alternative crop, right? Because cotton's got such a unique machinery complement on the harvesting side that if you don't plant that, and all of a sudden what are those new pickers, $800,000 and up, and you can't use that one, well, what does idle equipment cost you? So again, these are some of the other future considerations that we're looking at, but we're trying to get to a point where we can end up evaluating those cost trade-offs based on a specific operations information to end up assigning a value to the capacity and also a per acre cost. with that, I will take any questions that you might have. Well, thank you.
I'll just leave with one final, and I just did the calculations. If you look at trying to hit the corn window early in Tennessee in early April versus late April, and we get a 15% yield drop, then you're looking at $3.50 corn. You're looking at about $92 an acre you didn't get from that field, and you still have all the crop inputs as far as fertilizer and seed, and so that's the thing that it's hard to put into what Aaron's been talking about. There is some recovery, I guess.
Well, and if you go back to this here, dollars per hour, you said $92 an acre. Well, this is per hour. I mean, if you're planting even 20, these numbers are important. I mean, they have a significant impact on what your total operational costs are for planting. So again, I think it's really important to look at these numbers. And then the other one that I think is something that there needs to be at least an understanding of is if these windows continue to move the way they have, how does that affect those types of decisions?
Appreciate y'all hanging with us until the end.
Very good and thorough. Thank you both.
Agreed.